Okay, so now our next topic is de Moivre's theorem. So in this theorem, what we have to do is we have to prove that cos theta plus minus iota sine theta to the power n is equals to cos n theta plus iota sine n theta, means the variable or the fraction or the number given in the power of cos theta plus iota sine theta, that power will be the part of the angle. So let's see. To start, we have to prove this. So we'll start by e to the power iota theta is equals to cos theta plus iota sine theta. As we ended in Maclaurin series, we have learned this equation. So now what we'll do, we'll take it to the power of n. For suppose e iota theta to the power n. So it will become cos theta plus iota sine theta to the power n. So we can simplify this by writing e to the power I n theta is equals to cos theta plus iota sine theta to the power n. Let's name it equation 2. From equation 1, we see that it's given that whatever will be in the theta, it will be written with cos, that angle, that number will be written with cos as well as with sine. So in this case, when we have e to the power I n theta, so this n will be written with cos as well as with sine. So it will become e to the power I n theta is equals to cos n theta plus iota sine n theta, and we'll name this equation 3. Now what we have to do is combine this equation, the right hand side of this equation, with this equation. So now it will become cos theta plus iota sine theta to the power n is equals to cos n theta plus iota sine n theta. Now we'll name this equation A. You can say that half of our work is done. Now the positive side is done. Now we'll have to see the negative sign. We have also studied in Maclaurin series that e to the power minus iota theta is equals to cos theta minus iota sine theta. So it means that when the theta is negative, there will be a negative sign between cos and sine. So simple. Now we'll take this expression to the power of n. So it will become e to the power minus in theta is equals to cos theta minus iota sine theta to the power n, and we'll name it equation number 4. Now what we have to do, we have seen in equation 3, whatever is there in the angle, it will come with cos as well as with sine. So e to the power minus in theta will become cos n theta minus iota sine n theta. Call this equation 5. Now what we have to do, simple, we have to combine equation 4 and 5. So it will become cos theta minus iota sine theta to the power n is equals to cos n theta minus iota sine n theta, and we'll call this equation B. Done. We are done. Cause we will now just combine equation A with equation B. And you can see cos theta plus minus iota sine theta to the power n is equals to cos n theta plus minus iota sine n theta. Hence proved. Assalamu alaikum. So my name is Dua Salman and I study in the first year of BCIT. My roll number is 9 and my section is section A. So today the topic of our discussion will be Maclaurin series. I know its name is a bit tough and you will think that it's not easy, but trust me, once I explain you this, you will find it very easy. So our main target is to prove this equation e to the power I theta is equals to cos theta plus iota sine theta. So let's start. So first we'll take fx is equals to f into 0, matlab derivative of 0. Then we'll write x, f prime 0. Then we'll write x square upon 2 factorial, f double prime 0, x cube upon 3 factorial, f triple prime 0. And in this way it will continue on. Then we will take the derivative. Derivative of fx is e to the power x. Derivative of 0, which is a constant, so it will be 1. Likewise, first derivative of 0 will be 1, sorry. So it will be x here, and here also it will be 1. So x square upon 2 factorial likewise x cube upon 3 factorial, x4 upon 4 factorial, and x5 upon 5 factorial. So, and yeah, it's already given that cos theta is equals to 1 minus x square upon 2 factorial plus x4 upon 4 factorial, and this series will obviously continue on. It means that when we are talking about cos x, so the terms involved in cos x will be even, as you can see. Likewise, when we talk about sin x, you can see x minus x cube upon 3 factorial, x5 upon 5 factorial, and so on. So here also you can see that in sin, all the terms will be odd, 1, 3, 5. In cos, like x power is here 0, so 0, 2, 4. Okay, then what we'll do, we will replace all the replace all the x in this term with I theta. Okay, it's very easy. E to the power I theta plus 1 plus I theta plus I square theta square upon 2 factorial, I cube theta cube upon 3 factorial, I 4 theta 4 upon 4 factorial likewise. Then what we'll do, we'll simplify it. For example, iota square is equals to minus 1. So it will become minus theta square upon 2 factorial. Iota cube is equals to minus iota. So it will become minus iota theta cube upon 3 factorial. Iota 4 is equals to 1. So it will be theta 4 upon 4 factorial. And iota 5 is equals to iota. So it will become iota theta 5 upon 5 factorial, and so on. Then our next step will be, we'll arrange these terms. All the terms involving iota we'll write them together. Okay, so 1 minus theta, and all the terms involving iota will be written together. So our next step will be that we'll take iota common out of all these 3 terms, and so on, unlimited terms. Okay, and as mentioned above, the one with the even power is equals to cos x. So we can write cos theta here, and plus iota, the one with the odd power, is equals to sin x. So we will write iota sin theta. Now, as we have studied earlier, that z is equals to r cos theta plus iota sin theta. So we can replace this cos theta plus iota sin theta with e to the power I theta. So now it has become z is equals to r e to the power I theta. Now let's see, in this condition the theta is positive, but what if the theta is negative? In that case, we will write e to the power minus iota theta is equals to cos minus theta plus iota sin minus theta. Means the angle that we have put here is negative. But cos minus theta, whenever we'll put a negative angle in cos, it will always turn out to be positive. You can also check it through calculator. Well, I don't have calculator, or I would have shown you. Well, so cos minus theta will be equal to cos theta, and sin minus theta, if we put a negative number, the answer will also be negative, so it will be minus sin theta. So we can say that z is equals to r e to the power minus I theta.